Alright, here we go with our final set of notes in the homeostasis and transport unit. This one on facilitated and active transport. So we'll talk about our last type of passive transport and then move on and discuss our active transport. So our last type of passive transport that we're going to talk about, I'm going to write that here because it is pretty important that we remember that this is a passive process. Does that require energy? The last passive that we're going to talk about is facilitated diffusion. The word facilitate means to help, so facilitated diffusion is just diffusion with the help of proteins. And there are two different types of facilitated transport. The first one that I want to talk about is called carrier proteins. So these guys are just proteins, like we see right here, that can carry, literally carry, larger molecules like a glucose or something else that's big and can't fit through the cell membrane on its own. These guys carry these molecules across. They help the molecule through the cell membrane. Without their help, these guys would not be able to make it through. They would bounce off. They wouldn't be able to make it. They need to go through that helper protein. The other type of facilitated transport is called an ion channel. Right? This is a tunnel, basically, that allows things with a charge, so things like sodium, which is a positive charge, or potassium, this is potassium, or calcium, or chloride, which has a negative charge. These things normally, again, because they have a charge, would just bounce off the cell membrane. They couldn't get through. But with an ion channel, this opens up a space that they can get through, that their charge doesn't matter. I like to think of it like insulation around a wire, right? If you grab onto a wire that has insulation, you don't get electric shock. But if there's no insulation there, you could get an electric shock because those charges can transfer. So in this case, it insulates these guys so they're able to move through without just bouncing off. And again, because this is passive, it's really important to remember that both of these go down the concentration gradient. So they have to go from an area of high concentration to an area of low concentration. Right, you see here you've got 1, 2, 3, 4, 5, 6, if you want to count this guy, 7, high concentration to only 2. So they're going down that way. Right? If there were 30 of these molecules down here, then there would be a high concentration and they would be going the other way. But it's not. We're going from high concentration down to low concentration gradient. And just it can go either way. It can go, into the cell or out of the cell, depending on where that concentration gradient is. So you don't need to write this because you already have it. Just want to review real quick. The passive transports, the one that uses no energy. We talked about diffusion and osmosis already, movement of anything down a concentration gradient. This is specifically water down a concentration gradient. And these are other things that are still moving down the concentration gradient. They just need some help. In this case, they get help from carrier proteins or ion channels. Now we're going to move on and talk about our active transport. These guys are going to use energy. Examples of these would be the cell membrane pumps in endo and exocytosis. So our first example of active transport, remember that molecules now are moving against the concentration gradient. So it's like if you're paddling a canoe against the flow of the stream, you're going to have to use some energy, right? So in this case, the molecules are moving from low to high concentration gradient. So these guys are going to go up the slide, and you have to use some energy if you want to try to walk up a slide the wrong way, right? The most common example of active transport would be this guy here, like the sodium-potassium pump. Think of a pump, like when you're pumping up your bike tire, you have to use energy because you're putting more pressure in there. So these guys are moving things against the concentration gradient. And this is a really, like I said, popular example. In this case, we have a sodium-potassium pump moving sodium and potassium against their concentration gradients. So they're moving 3 sodium ions out of the cell, 3 sodium out, and each time they do that, 2 potassium come in. So those pumps are moving things against the concentration gradient. 3 sodium leave, 2 potassium come in. The other example of active transport are endo and exocytosis. So this is how a cell ingests or removes large amounts of material, and it actually does this by moving and surrounding and engulfing whatever it wants to eat or get rid of. So for this case, endocytosis is in. Endo means in, so this is when cell is bringing material in. And exo, think exit, is when the cell moves material out of the cell. So if you look down here, you can see it would take some energy for this cell to kind of surround this little guy and surround this thing that it wants to eat, and it forms a vesicle around it. Right? It might fuse with that lysosome. Remember those other vesicles with the digestive enzymes, does this digestion thing, gets all the stuff that it wants. Hey, these are the good things we want to eat. These are the things that we don't want. This is the waste, and eventually it's going to merge back with the cell membrane and just kind of spit all the other stuff out. And that's going to require energy because you're moving things around inside the cell. So both of those, cell membrane pumps and then endo and exocytosis, are examples of active transport. And with that, we are done with notes for this unit.